Okay, interesting question here. Would multiplying two functions with the discontinuities give you a continuous function? And the general answer is yes, this is possible. It is not always true, but it is possible. So what I'll give you is some examples where this is possible. You can see on the left side we have a function in red, which is for the non-negative values of x. It is 1. Let's say this is 1, and for negative values of x, it's let's say -1. So this is -1, and it is defined for all real numbers. Make sure it's defined for all real numbers. For negative numbers, it's -1. For non-negative, it's +1. And we have another function in yellow, which is the opposite. It's kind of for non-negative numbers, it's -1, and for negative numbers, it's +1. And what happens when you multiply them? When you multiply these two functions, let me see if I can get them on top of each other. So what happens when you multiply them? If you see clear enough, close enough, that when you multiply the non-negative parts, the red function was +1, but the yellow function is a -1. So when you take the product becomes a -1. So because 1 times -1 is -1. So let me do it in blue. So for non-negative numbers, the function becomes -1. And for what happens for the negative values, the red function was -1 and the yellow function was 1. So when you take the product, it again becomes -1. So you see clear enough that the product is a constant function which is -1, but the individuals were not. The product is a continuous function, a constant -1, but the individual functions were discontinuous. This is kind of a example, but you can have simpler examples in kind of a, you can cheat around. I'll give you another example. Here you have another example where you have a function in red, which is, it's a crazy function. It's a crazy function. It goes something like this, gets jump discontinuity over here, and then goes something like this. It's a crazy function. The only important thing is that it is defined for all real numbers. It obviously has a discontinuity, and on the other hand, we have a yellow function, which is almost always a 0 except for this point. It is here, it's non-zero. So here it is some point over here, and it has a removable discontinuity, but it is defined for all real numbers. It is discontinuous. Now let's see what happens when you multiply them. When you multiply them, again, let me see if I can get them on top of each other. If you multiply them, since the yellow function was 0 almost everywhere, you'll realize that the product will be 0 almost everywhere. Okay, let's see. The product will be 0 almost everywhere. But since the red function was 0 at this particular point, the product will also be 0. So you can see, I know my drawing is not that good, but the product is a constant 0, which is a continuous function. So again, you have another kind of a cheat function or cheat example where the individual functions were discontinuous, but the product came out to be a continuous function.